Potential divider means we have to put such elements in the circuit which divides the voltage of a battery. Okay, so I'll take a very simple example of a circuit where there are two resistors whose resistances are R1 and R2, and they are connected in series across a battery. And let's say this is a switch, and that's it. No other elements are required. Now, since it is a series combination and the net voltage supplied by the battery, in such cases, we always consider internal resistance to be 0. Even if the internal resistance is something, then just try to recall we had discussed V is equal to E minus IR, where V is the net voltage supplied by the battery. Okay, so even we can just say that V is the net voltage, and in the direction of this positive terminal will take current. So now when current will go in both the resistors, they will have different potential values because V is equal to IR is the formula which we will be using. Okay, so for the first one, I will write V1 is equal to IR1. They have same current, but their resistances are different. So they will have different potentials. So V1 is IR1, V2 is IR2, and logically V is equal to V1 plus V2 because that was the net supply voltage. So this is that equation which we can call as Kirchhoff's voltage law. Okay, where the net voltage supplied by the battery is equal to the sum of voltage which is there in the circuit. Okay, so in other words, I can say that this potential is being divided in both the resistors. Now, how it will be divided in both the resistors? So it will be divided in the direct ratio of resistances. R1 is to R2. Over here, voltage is directly proportional to resistor. So since they are directly proportional, I can say that voltage will divide in the direct proportion of resistor. Means more will be the resistance, more will be the voltage. Okay, more will be the resistance, more will be the voltage. So that's why in the ratio of R1 is to R2, that voltage will divide. We can directly get the value of V1, V2 like this, but we have another way. Let's say I'm using this R1 is to R2 ratio. So for that, I can write V1 is equal to R1 over R1 plus R2 times V. The net voltage across the circuit was V, and V1 is R1 over R1 plus R2 times V. And similarly, I can write V2 as R2 over R1 plus R2 times V. This may look difficult over here, but let's say I have net voltage supplied by the circuit is 15 volt and the resistances are 10 volt, 10 ohm and 5 ohm. Okay, I'm just taking a rough example to show you the application of this thing. Okay, now what I'm saying that it will be divided in the direct ratio of resistance. It means that the first one, V1, will be 10 over 10 plus 5 times 15. Okay, so if you will solve this, you will get 10 over 15 times 15, that is 10 volt. And similarly, when you will solve for V2, in V2 you will see it will be 5 over 10 plus 5 times 15, and that will be 5 over 15 times 15, which will be 5 volt. So the net voltage across both of them is 10 volt and 5 volt, and across both of them together it will be 50. So how did we get those? Using this formula. Okay, so this is called as potential divider circuit. It looks difficult, but it is not. It is just a series combination in which we are dividing the potential in the direct ratio of resistances.